Hello, for calculus students. This is a recording intended to help you out with solving trig equations. So this is related to Unit 3, Topic 3, and Objective 2, which is going to be solving equations. We're going to start off with some pretty simple ones for now. And then as we get into learning more of the double half angle sum difference formulas, we might end up with some more complex solving equations. But for now, we're going to stick with some pretty basic linear quadratic solving. So your icebreaker was, if you could instantly become an expert at something, what would it be? Okay, so we're going to just do some examples and then practice in this video. All right, so our first example is solve on the interval from negative pi over 2 to pi over 2, sine of theta is equal to 1. So I'm just going to go through the steps we talked about last week. So with inverse sine, right? So we're doing inverse sine of theta to free up theta equals inverse sine of 1. All right, so theta is going to be equal to whatever angle measure gives you a sine of 1. There's only one that's in this interval, which is pi over 2, right? Pi over 2 has a sine of 1. So pi is equal to pi over 2. If it said to answer in radian measures, you would say pi over 2. If angles, you would say 90 degrees. All right, and solving on this interval becomes important, as you'll see later. Okay, so now we're going to get into something a little bit more difficult. So solve on the interval from negative pi over 2 to pi over 2, cosine of x minus sine of x equals 0. Okay, so what I'm going to do is I'm going to try to isolate x, or at least figure out how I can somehow combine this cosine and sine expression. So if I added sine of x to both sides of the equation, then I'll have cosine of x is equal to sine of x. Now, you could use your math intuition and think, okay, well, if I'm on the interval from negative pi over 2 to pi over 2, where is the one place where my cosine of my angle is equal to my sine? And it is pi over 4, or 45 degrees. So you could use that intuition and figure that out, but I want to show you just a process in case you get stuck. So if we divided both sides of the equation by cosine of x, we would end up with 1 equals tangent of x. And then we can use our inverse trig. So we can say the inverse tangent of 1 is equal to x. Well, what angle has a tangent of 1 that falls in this interval? Again, pi over 4, or 45 degrees. Okay, so those were some examples that only had one solution, but sometimes we'll get into some examples that have multiple solutions. So this one says solve on the interval from 0 to 2 pi. So if the degree is greater than 1, that means the highest exponent, factor or be prepared to have more than one solution. Be prepared to have more than one solution. So this equation is 3 tangent cubed of theta equals tangent of theta. So I'm going to remember that I'm going to maybe trying to factor is a good idea. So if I subtract tangent of theta from both sides, I'm going to have an opportunity to factor and simplify. So 3 tangent cubed theta minus tangent of theta equals 0. Now see how out of this expression, there's a greatest common factor of tangent of theta. So I can pull a single tangent of theta out of this expression. And what am I left with? 3 tangent squared theta minus 1 equals 0. Okay, now I can set both sides of this, I can set both factors equal to 0, right? Because if this times this is 0, then this has to be 0, or this has to be 0. So let me set tangent of theta equal to 0, and let me set 3 tangent squared of theta minus 1 equal to 0, right? So if I take the inverse tangent of both sides for this equation here, that gives me 0 equals, should be 0, inverse tangent of 0. So if I'm solving on the interval from 0 to 2 pi, that means one full rotation around the unit circle. So where is tangent 0? Tangent is 0 at 0, at pi, and again at 2 pi. So my answers will be 0, 0, pi, and 2 pi. So that's part of my answers, but not all of it. I have the other factor, 3 tangent squared of theta minus 1 equals 0. So I can add 1 to both sides, giving me tangent squared, 3 tangent squared of theta equals 1. Now I divide by 3, tangent squared of theta equals 1/3. Take the square root. Let me start working up here. Take the square root of both sides to get tangent squared of theta into tangent of theta. All right, so that'll be tangent of theta equals plus or minus the square root of 1/3. Well, 1 over root 3 is a tangent that we have seen before, right? We know that there are a couple of places on the unit circle where I have a tangent of 1 over root 3, right? Or root 3 over 3 if you're rationalizing the denominator. So let's look at, let's just kind of sketch this out. Where on the unit circle do I have a tangent of root 3 over positive or negative root 3 over 3? It's going to happen at pi over 6. That'll be positive. It's going to happen at 5 pi over 6, except it'll be negative, but that's okay because we want plus or minus. It'll happen at 7 pi over 6 and again at 11 pi over 6. So these are the 4 solutions to this part of it. So theta is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All 4 of those radian measures, or if you were doing angles, it's 30 degrees, 150 degrees, 210 degrees, and 330 degrees, all have all have tangents of root 3 over 3 or 1 over root 3, plus or minus. So there are actually 7 solutions to this equation. Okay. Now, if you had divided both sides by a tangent of theta to simplify it, you would completely miss this solution. So it's really important to remember to factor and not lose sight of that. The fact that you can't just start and divide by tangent of theta to quote unquote get rid of it. You really want to make sure that you account for it when you're solving. Okay. Here's another one. So 2 cosine squared of x plus 3 cosine of x plus 1 equals 0. I did this in the video that you hopefully watched when you were doing your asynchronous paired deck assignment. This is actually a case where you need to do that binomial factoring. So if you were factoring, remember that you need to have, you have your a, which is your coefficient to the squared term, b, which is the coefficient to the linear term, and then c, which is the constant. A times c is something is going to be your product. B, or 3, is going to be your sum, right? So product, sum, what adds to 3 and multiplies to 2? It's going to be 2 and 1. So you can split the middle term to factor. So 2 cosine squared of x plus 2 cosine of x plus 1 cosine of x plus 1 equals 0, right? And then you have 2 pairs of terms that you're going to group and factor the greatest common factor out of. So 2 cosine of x can be factored out of these 2 expressions, leaving me with cosine of x plus 1. 1 can be factored out of this expression, leaving you with cosine of x plus 1. So now I factor one more time. Cosine of x plus 1 is the greatest common factor between these 2 terms. So I have cosine of x plus 1 times 2 cosine of x plus 1 equals 0. Right? So now, just like in the last problem, I set this factor equal to 0 because that has to be true for this to be 0. And I set this factor equal to 0. So cosine of x plus 1 equals 0. And then I'm going to do 2 cosine of x plus 1 equals 0. All right, so let's solve here. -1 minus 1. cosine of x equals -1. I'm not going to write inverse cosine here, but the only part of this interval where you have cosine of -1 would be pi, right? Because if you're going one revolution around from 0 to 2 pi, this is the only spot where you have a cosine of -1. Okay, and then for this next factor, 2 cosine of x plus 1 equals 0, subtract 1, subtract 1. So I have 2 cosine of x equals -1. Now I'll divide by 2. So cosine of x equals -1/2. Okay, so cosine of x is -1/2 up here at 2 pi over 3. And it's also -1/2 here at 4 pi over 3. So x is equal to 2 pi over 3 and 4 pi over 3. So you can see why the interval is important, right? We need to specify what the domain restriction is, or however, so we can kind of answer giving the correct answers, because otherwise we would either assume that we were working within our normal domain restrictions, or that, we don't know what they are. So that's why this is important. Okay. All right. Here's another one. It's just another degree greater than 1, but it's one that I'm not going to need to factor. I can actually take the square root. So I have 2 sine squared of x minus 1 equals 0. I'm going to add 1 first. So 2 sine squared of x equals 1. Divide by 2, sine squared of x equals 1/2. And then I'm going to take the square root of both sides. So sine squared of x, sorry, not sine squared of x, sine of x now, because we did take the square root, is sine of x is 1 over plus or minus 1 over root 2. Okay. And remember, I'm stuck in this interval, right? So I'm looking for, where do I have a sign of plus or minus 1 over root 2? Well, 1 over root 2 is the same as root 2 over 2. And so that's going to be at 2 places. It's going to be at pi over 4, and it's going to be at negative pi over 4. So those are going to be our 2 answers here, pi over 4. You could just say plus or minus pi over 4, and that will fit the bill. Plus or minus pi over 4. Okay, so now try these 3 and see how you do. Pause the video and I'll see you in a minute as you try these. All right, so I hope you had a chance to review and work on these problems. These are the answers to them. Sorry, the little dashboard here covers up the bottom. I have to remember to stop writing below this line. So but just take a look, pause the video if you need to, wherever you need to pause it, and take a look. The challenge problem had a sneaky Pythagorean identity in it. Cosine squared plus sine squared is actually equal to 1, and that makes the rest of it easier to solve. Okay. All right. So that's all I have for today. Thank you for watching. And then you have your exit question, and that's it. Thank you so much. Have a great rest of your day. Email me if you have any questions. Thank you. Have a great one.